Hi. Well, first I have to say I'm sorry for two things. The first is that I'm the only thing between you and the beer party. And the second, my voice, it's not very good today. So I will talking about progressive web apps. I called my talk Demystifying Progressive Web Apps because I think that building a baseline PWA, it's actually quite simple. And today I will give you the steps to do your first PWA. So first, allow me to introduce myself. When I was a kid, Superman was a journalist, so I wanted to be a journalist. Apparently, I was not very good in dreaming big because I could choose to have all the superpowers, but I only wanted to be a journalist. But then, my parents gave me my first computer, and since then, I've spent most of my life building stuff with computers. Like Google talked in the morning, I start with BASIC and with the Spectrum 48K, then an 128K. I also had an Amstrad 64, and basically I've been playing with computers and working with computers, I don't even know for how long. Currently I work at Guest-Centric, a travel tech company. We have a great team there, and we are hiring, so please take a look at our website. I had to say this, or else my boss will kill me. So let's get to the chase. What's a progressive web app? The first thing that we will see is look to what Google says about progressive web apps, because actually Google is the main pusher for these technologies. I will try to talk a little bit about why Google is trying to do this. But for now, let's look at what they say it's a progressive web app. So Google uses 10 points to define a progressive web app. The first one that probably you weren't expect, it has to be progressive. This means that the user experience will vary according to the browser capabilities, but the experience will stay better and be progressively improved as long as the user interacts with the application, and also depending on the functionalities available on the browser or on the system that the user is using. Then they have to be responsive. The application must work on every form factor, being mobile, desktop, or even any form factor that may emerge. It's connectivity independent. The application must work even on flaky connections or even if no network is available, like a native app. And then it's app-like. Because of the application shell approach, you can load all your app structure and then use the network only for the data. The applications are also what they say fresh. And fresh means that they are always up to date. There is no need to update your application, to go to the App Store and order your system to update, because as long as you're using the application, you are always on the last version. Sorry. I haven't used this yet, so let's go. We are on fresh. Then they are safe. This means that PWAs must be served over HTTPS. Actually, some of the core technologies that allow to meet all of the PWA's checklist require HTTPS. Then the applications must be discoverable. This means that they can be identified as an application via even search engines. They must be re-engageable. This means that you can re-engage with your users using, for instance, push notifications. Then, of course, since we are talking about applications, they are installable. This means that the user, at any time, can choose to add the application to the home screen. And finally, they are linkable. Linkable means that you can share the application with a simple link. There's no need to enter on the App Store, nor anything like that. You just share a link, the other person opens, and it's using the application. So it's a quite big definition, and probably not a better way to explain, for instance, to a customer what a PWA is, because I think it's never a good idea to start talking to someone, unless it's a geek like me, and tell him, look, to explain you this, there are 10 points, because probably at the second or third point, you will lose the person's attention. So I try to build a definition, installable web apps that work offline and have access to certain system-level resources like push notifications and background sync. Of course, this doesn't have all the details, all the technical specifications of the 10 points, but I think it pretty much says what a progressive web app is. It's like a website that you can install. Of course, saying website, it's a bit simplistic, because you will probably will not choose the same structure for an application than you would choose for a website, but in common language, we could say something like that. A few years ago, on the iPhone launch, Steve Jobs said something that looked a lot like this. And some people say today that Steve Jobs was the father of PWAs. I think it was not the case, because, for instance, you don't see any reference to this quote about working offline, because the premise of the iPhone, it was the opposite of it. It was a device to put you always online, and that was one of the big keys of the iPhone. But then this great idea, presented in 2007, had a little problem. It failed. 1 year later, I think it wasn't even a year later, Steve Jobs was saying that, after all, this thing of building applications to the web browser was not such a good idea. And what really was great is to have an app store and have an SDK to develop applications for the iPhone. So you might ask, if this failed before, why should we be here looking to this today? Well, there were a lot of things that have changed since then. The technology changed, also the browsers, and of course, some of the speakers here today also talked about that market time that you have to ship fast, and that's one of the big advantages of the progressive web app, because instead of developing 3 applications, or at least 2, one for Android, another for iOS, you could build one single application that will work for all the systems. And this, of course, it's very important for companies, because instead of having 2 or 3 teams developing different applications and giving support to different applications, they can have one single team to build the applications for all the platforms. And then, of course, today we have Google pushing this concept, because, like I said before, the PWAs must be discoverable. And discoverable means searchable. And we all know that Google, it's king on search. So they have all the interest in having the applications on the web instead of having them on App Store, when Apple seems to be more dominant and even more profitable. Then, of course, we have another big player also pushing this. It's Microsoft. Microsoft has, of course, a problem of application gap on their platform. And PWAs can be a good way of fighting this problem. One of the things that Microsoft is doing, it's adding PWAs to their App Store. On Windows, you can even install PWAs on desktop. So I think times are a bit different. I think the concept, it's not there yet. It will have to evolve. But I think it's a good time to start to look at this technology, because, as we know, on our day, sometimes these things happen really fast. So let's start on the second part of the presentation. And like I said, the objective here is to help you build a baseline PWA. What's a baseline PWA? Google has two levels to define progressive web apps. They have the baseline, which we can say it's an application that has the minimum stuff to be considered as that. And then there's the exemplementary PWA, which has all the full features and some more extra points than the baseline. Also, the baseline are points that can be automatically checked by tools. So you don't need users. You only need some automatic tools like Google Lighthouse that will help you verify if your application is following the baseline checklist. So the first thing on this checklist that I had already talked about, because some of these things overlap with those 10 points that I talked at the beginning, it's that they must be served over HTTPS. So no big discussion here. Of course, they have to be responsive. It was one of those 10 points also. They have to load all URLs offline. This means that the application must work offline, even if the only things that it's presented to the user, it's a default page saying that the network is not available. The important point here is that the user can never see the default browser offline page. It has to see a page generated by the application stating that the network is not available. Then, since the applications must be installable, we have to provide data to that installation. Oh, sorry. Then, first load, even on 3G, because PWAs are connectivity independent. I think this is not moving. Yeah, we have typo here. This point is that the PWA must work cross-browser. So it has to work on all platforms. Then the app transitions, of course, must be fast, because in native applications, all the transitions are pretty fast, and that's exactly one of the points that sometimes people prefer to use apps instead of websites or web applications. Then, finally, each page has to have its own URL. Of course, this list, it's big for the time that we have, and also most of these points should not be a problem, since we are here surrounded of designers and front-end developers. So we will look to two of the points here. It's that all the application URLs must load offline, and the metadata to install the application must be provided. So let's start looking to the manifest.json. This is the file that provides the data to install your applications. Pay attention that having a manifest file on your application doesn't guarantee that the user will be popped with the message asking him for installation, because the PWAs are progressive. It only happens if the user comes back to your application and it has to engage with the application at least for 30 seconds. So if you are trying to build an application, don't expect that when you go to test, open the page and you see the pop-up, because that will not happen. You will have to engage with it and probably do some reloads before the site asks you to install. So then, looking to the manifest file, at the beginning, we have the short name and the name. The short name will appear on the home screen under the icon, and the name will appear on the pop-up screen. If you want to use the same name on both of them, you can omit the short name. Then there's the icons section. You can specify as many icon sizes as you wish, and then the browser will automatically select the one that appropriates for the resolution that the user has. But there's an important point in here. You have to provide at least these two sizes, the 192 and the 512. Because these are the default sizes for the splash screen and for the icon. So if you don't provide these two, probably the user will not will never see the installation pop up. Then we have the start URL. The start URL, it's the page that will be displayed when your users open the application. That it's not necessarily the first one, the same one as they were when they decided to install the application. Then, of course, background color, it's self-explanatory. And then we have the theme color. The theme color will affect the URL bar on the browser. Then there's also here an important setting. It's the display. Here I choose standalone, because standalone will behave like a native application. The user will never see the browser URL once he chooses to install the application. Then there's the scope. The scope, it's basically the root of your application. So, moving forward, if you have a completely valid manifest file, and if the user engages with your site, something like this will happen. You are on the site. Sorry, I just can't. You are on the site, and there will be a pop-up asking the user if he wants to install the application. Remember that this only happens if the user engages with the application. If he says, yes, I want to install, he will see a message for confirmation, and once he confirms, next time he opens the application, it will be something like this. There's a splash screen with the name, and then when the user opens the application, there's not browser URL anymore. It just looks like a native application. As you can see, I built a not very useful application to show you this concept. I will share the URL later and also the source code. So, to make this possible, we already know how do we install our application. It's basically creating a valid manifest file. This manifest file also allows the search engines to identify your website as an application. So we also comply with this point. And now we go to the second part. The second part is all URLs must load offline. How does this is possible? It's possible thanks to the service worker. So the service worker, it's basically a proxy that will sit between your application and the network when available. It's really important, this point, when available, because if the network is there, the service worker will sit between your application and the web, and if the network is not there, your app will still do the requests to the service worker. So service workers are now available on all the main browsers. They were not available, I think, only on Safari, but since the beginning of this year, Safari only supports the service worker and most of the technologies that make PWAs possible. So also Apple, it's moving on this direction. So here it's a scheme from Mozilla Foundation showing how does the service worker stays between your application and the internet. And basically, as you can see, if you don't have the service worker, there's a page and the request goes to the network. Then, if you have a service worker, a fetch event, it's called, and then you can decide if you want to simply proxy the request. And when I say proxy, I said the worker goes to the network, takes the page or the file and takes it to the application, or you can choose to do some manipulations, like get the page from the cache, and even go to some local storage data and put it on that response. So let's look a bit to service worker lifecycle. So the first thing, it's the installing. The installing, it's what happens when you load a page for the first time, or when you load a page that has a new version of the service worker. Then we have the installed. When the service worker is installed, it's not necessarily working, because if you have other versions of the service worker on other tabs, it will not start to hijack the requests from the page you are in immediately. Of course, this can be bypassed. There's an option. You can just skip waiting, and this new service worker will start immediately. Then, after it's installed, there's the deactivating. Deactivating event, usually it's used to do things like clear old caches from previous versions of service workers and all that kind of stuff. And then, of course, there's the activate. When the service worker is activated, anytime there's a network request from your application, it will go to the service worker. And of course, like I said, when the worker is installed, it's not necessarily active, because there might be other workers on other browser tabs, for instance. This state, it's called the redundant. Every time a new version is installed, the service worker becomes redundant, and then it's replaced by a new one. We just dispose him, and that's it. So from this life cycle, there are a couple of events that are associated with them. There's the install. It's what happens when the service is installed. You can say, look, just put me all these files into the cache immediately, and once the service worker is installed, it will be doing this. Then there's the deactivate that I already talked, and there's the message. The message, it's basically an event that will allow to send messages between service workers that are, for instance, on different tabs. And then we have the functional events. We have the sync, the fetch, and the push. Today we will be looking to the fetch request. So we are running out of time. One thing that I forgot to mention about service workers is that they run on a separate JavaScript thread from your page. So this means that the service worker will never block your page from rendering or something like that, but this also means that you cannot do DOM manipulations on the service worker. So first step, registering a service worker. This is a pretty standard code. Every example that you see how to register a service worker will probably look a lot like this. Of course, different scope, a different file name probably, but the structure, it's the same. What I call attention in here is that before trying to register a service worker, we have to check if the service worker is available on the browser. Because if we wouldn't do that, then the application wouldn't be full cross-browser functional. Because if we open the application on a browser that not supports the service worker, the application will not load. And then, of course, there's the scope. The scope means that everything under this path would be controlled by the service worker. So any requests that are above this folder will not be controlled at all. All the requests under this folder will be controlled. So Another example, this is a service worker. Service workers are kind of agnostic of your website. This means that you can take this service worker and use it on any website or any application if you want. We can also use service workers not necessarily on applications. So let's look a bit at the code. At the top, I'm creating a cache key, and I gave a version to this cache key because when I update my service worker, I can opt to clear these caches if I need, or I just can keep all the differences even between different versions of the service worker. Because the only thing that makes the browser install a new version of the service worker is that the files are, it's a binary diff. This means that any difference on the service work file, even a simple space at the end, will make to the browser to reinstall the service worker. Then here, this is the install event, and on the install event, we are telling the service worker to immediately download one page called index.html and put it into the cache. And then finally, the fetch event, which is where we are more focused today. On this case, the fetch event, it's doing one simple thing. We simply try to check if the page exists on the cache. If it does, we return the cached version. If we not, we simply go to the network and get the version for that page. Of course, this service worker has two problems. First, we are only caching the index.html, so no any other page will be available offline, nor any other page, nor any other file. And secondly, we don't have any fallback for lack of connectivity. So if the network is down, the user will see the default browser offline cache. So let's do some improvements on this code. This time the code doesn't fit on the screen, so I have breaking this into pieces. So the first piece is the install, and now we have here one more thing, which is the fallback page. And then on installation, as you can see, we are also adding to the cache the fallback page. This means that as soon as the service worker is installed, we will have two pages available offline, the index.html and also a fallback page that we can use when situations that the network is not available. So then, on the fetch, we can also improve things. And now, this new fetch event does something else. If the page is available, it will get it from the cache. But if it's not, it will go to the network. But after retrieving that page or that file, it will put it into the local cache. This means that as long as the user is going to use the page and browsing the application and browsing to different pages, they will be available offline later. So this is a much better experience and also a very aggressive cache strategy. So here you may think in different cache strategies and different cache keys for different file types, for instance, or you can have caches just for pages, another cache just for static assets. It's whatever you want to do. And then we also have a catch for the exception that occurs when the network is not available. If the network is not available, on this case, we will present our fallback page. And that's it. At this moment, we have a PWA that caches all the pages that the user searches, and then if the network is not available, it will present a fallback page. Finally, if we are creating so many caches, we should also clear the cache when a new version of the service worker is installed. So here we have also a very how can I say, standard code, which basically you can choose what are the caches that you want to keep, and all the others will be deleted. And I'm running out of time. So finally, to end, I would like to talk about some tools. Let's do this quickly. I already mentioned Google Lighthouse before. It's now available on Chrome. And basically, it does all the tests for the baseline PWA. It's a very useful tool. It can tell you if your manifest file has any problem, if your service worker is failing to install because he's not able to download some pages, and that kind of stuff. Then, some more. The Service Worker Cookbook from Mozilla Foundation. It's a website with tons of recipes for service workers, like offline first, online first, cache with offline. Probably you can find a solution for most of the use cases, except if you have a very complicated cache strategy that it's not very standard. And then we have the Pwi Builder, which is a simple website that will generate icons and manifest file for an application as soon as you provide it with an URL. And that's it. This is the final application. This is my contacts, and this is the end. Thank you very much. Don't know if there are questions.
Hi, Sergio.
Hi.
Thank you for your presentation. In the beginning, you were referring about instead of you using PWAs, instead of you creating different applications for different operating systems, you can create only one. This is more a design niche question. There are some UI, user interface differences between the different operating systems. How do you deal with that with one single application? And if you know any examples of any good examples that you can share with us?
Well, I think that one of the things that you could do is, for instance, try to detect the device and use a different style sheet or different visual components for the device. But still, I think it's still less work than doing 3 different applications, because you can have the same team building different visual components to the different platforms, instead of having a team specialized in Java, another in iOS development.
Hey, hello.
Hi.
You mentioned there in the tools, and I was expecting to see some kind of tool that would generate the bare bones or this base structure for PWAs, because last time I checked, and it was some time ago, it was super hard to just get started with PWAs. So is there already any tool that already does the big, like,
yes,
stuff?
I think there are some JavaScript frameworks. For instance, Ionic is now starting something for PWAs. And also, there's something I'm not sure. I don't remember, but there's a specific framework that it's just for PWAs. But if you Google it, probably it will be on the first results.
Okay, but then, so there are not many. Most of them, well, most of the work is still
Not that I know.
Okay.
But there are some.
Okay, thanks.
Well, I think that's it. If you want to try the application, it's available there, and Pedro did not hack my Bitbucket account.